All right. Hello, everyone. This is the cohort for cyber defense and countermeasures. Tonight, we're going to be going over lesson four. Lesson four is understanding process improvement and security operations. This is a very short lesson, so a lot of the information it'll kind of seem fast, but this is actually very important because these concepts are things that apply directly to the field, things that you're going to see um, common. You're you become a cybersecurity analyst, and some of the concepts we're going to go over here are some things that should be known for the exam. So for the first portion, we'll go over exploring security operations, automation concepts, understanding automation technologies, for the relationship between security information and event management, otherwise known as SIEMs, and security orchestration, automation, and response, otherwise known as SOARs. We'll also learn about the importance of processes and consistency in security operations. Just an intro video that kind of gives you an idea of it kind of applies it. I normally don't play this just due to the fact that I don't want to play a video on a video. You all can watch this at your own time because you all kind of are here to get some more of some in-depth information. So essentially what lesson four goes into is it talks about how SOCs, security operations centers, can make their environments more secure by um, essentially automating everything, putting everything in a centralized location. So when the operators are on the SOC floor, they can log into one centralized location and be able to do their work from one place versus having to log into a bunch of different systems. Um, Automation also allows events to trigger, and it triggers actions that can be taken in order to protect the network without human interaction. This essentially is not getting rid of the job of a cybersecurity analyst because some things do involve human interaction, but for the most part, there are a lot of actions that can be done um, from an automated standpoint, which is faster. Sometimes a human can't get to it, and a human will be able to essentially come on the back end and possibly unlock an account or take a box out of quarantine. But essentially, what we want to do first is we want to stop the activity through automation and then investigate later to prevent any further malicious activity in the network. Starting here, we're going to get into the Security Information and Event Management System, or the SIEM. Essentially, the best way to look at what a SIEM does is it takes events from multiple different event sources, takes different logs in. So it can take your network logs, it can take your PCAP, it can take your Windows event logs, it can take your Linux authentication logs, all the different logs, application logs, logs from the cloud, just everything. It can bring everything into one location so you can have a full visibility of what is going on across your network. So SIEMs are generally used for monitoring. They allow you to monitor, identify, and the operator can then respond to security events based off of the SIEM. You're able to possibly click links within the SIEM that'll kind of take you into different applications that can help you better respond to them, or you can also correlate events. So essentially, if you see a network issue come across, if you see some weird traffic come across within the SIEM, you can within the same dashboard, and we'll get into this later, within the same pane of glass, as they call it, you can click on a different type of log source or a different type of plugin and be able to look at information more in depth. So you can take a high level network log or a packet that goes across, do some investigation there, and then in the same location go into the host level logs to identify what's going on in the box. Um, the way seems different from SOARs is SOAR, so both of them alert, SIEMs and SOARs alert. The way SOARs differ is SOARs are, think of them as your playbooks. SOARs can actually respond to certain events in a way that can actually do the initial job of the cybersecurity analyst. It can cause for instance, if an account is doing something weird, a SOAR can essentially disable the account if it sees certain actions happen. The thing about a SOAR is you definitely want to make sure it's configured properly, because if not, if you have a false positive, what can essentially happen is it can start locking things out and start doing actions that you don't want it to actually do, and effectively slow down business operations. So ensure that your SOAR and your SEAM are tailored to your business operations, and ensure that before rules are put in place, especially in a playbook form, that they are vetted in a sandboxed environment or used vetted against test accounts. And that way you can actually see what the outcome will be if certain actions happen in order to prevent you from stopping business operations in case of a false positive. So here we have XOR. XOR is a commonly known application used in the field. So XOR is it's just a flavor of a different SOR. You can put carbon black in a certain mode, in game in a certain mode, where essentially it'll run playbooks. And essentially, what you see here on the screen is it kind of identified the if then or the algorithm that is taken to respond to certain attacks. If an attack has occurred, it has seen certain indicators, and then it goes through certain steps. Essentially, it works through an if and then statement. It basically says, is this, if it's doing this, then do this, then what is that? If it's doing that, then do that, and it goes all the way. You can't have them go to the point where it closes out the specific activity. It closes itself out as a ticket and basically shows you the results. That's kind of a more aggressive way of doing it, just because you kind of want to have some type of human interaction. So you want it to do the initial actions, but then stand by and wait for human interaction before it does anything kind of that can cause more damage to the network per se. So these are identifying tasks that can be utilized best within automation. Um, when you're trying to figure out if you want to actually implement automation into your environment, you have to first look at your business operations and figure out if it's right for you. This can be based on network traffic, um, flows, sensitive um, systems, sensitive servers that are related to your actual mission statement of your organization. And this will actually help you determine when you should implement automation or when it should just be log should be just put into a seam in order to determine in order to get the best possible outcome. So these are the different tasks that can assist you in identifying whether or not automation should be added. Essentially, the SOC teams determine what is the best implementation. The SOC team takes input from the business operations and the mission in order to determine how they can best protect the network, where automation can benefit, and where automation can have some undesired effects. And that those are locations where they would do more of a passive implementation, such as a SIEM instead of a SOAR. When we go to streamlining operations, all of this kind of comes together full circle to identify where we have some type of latency, some type of delays, where we can actually make processes more efficient. And then that'll actually help us drive where we can add in automation versus just putting in a seam. So if we're doing menial tasks within the SOC that should be automated, those are things that actually should be brought to the SOC team and identify that there's a use case that exists that would warrant streamlining and the implementation of streamlining or automation. So with this, um, just like any other organization or any other task that happens out, you want to make sure you're streamlining operations. That's kind of the key to properly, um, I guess, conducting SOC operations. Everybody has to talk. Everybody has to communicate. Because if you have one side of the SOC that doesn't communicate with the other side, or if you have one shift, you have a day shift that doesn't communicate with a night shift, it can cause issues where you have tickets that never get closed, or you have tickets that get closed too early because someone's investigating it, or boxes that are getting quarantined while someone's investigating it. So essentially, you have to streamline how you want to protect your network and streamline your communication, ensure that everyone is actually doing something that is contributing to a greater good as far as protecting the network, and there's kind of no lost work. And when I say lost work, it's if you're doing something and someone's already kind of doing that effort and they've already closed that out, but you didn't actually see a closed ticket or you didn't actually see the outcome of that investigation, it's doing double work, it's lost time because that operator could be working on something else. One of the good things is automation actually can prevent this, because automation, think of it as if it's set up properly, it could be that second person. So while you're working night shift or something and you're working on a specific ticket, you're investigating something, if something occurs that may be deemed as possibly malicious, your SOAR can actually run a playbook to stop that, and then it will basically add it to a queue. But you don't have to stop what you're doing to actually go to respond that to that event, because what that turns into is an idea called whack-a-mole, where basically you're running around, kind of closing all these doors to the adversary, or you're attempting to, but you're not actually stopping the adversary. You're not actually identifying the attack, building the chain, and actually doing good work when it comes to the role of a cybersecurity analyst. So, threat intelligence data. So, what feeds the scene? What feeds the SOAR? How do we know what we're looking for? How do we know that it's bad? It's threat intelligence. We need to be able to pull in threat intelligence from multiple different sources. We need to make sure it's the right intelligence based off of the industry or our specific need or use case within our organization. And we need to ensure that that intelligence is being fed into the creation of alerts or filters that our team can then use to identify malicious activity. So, threat intelligence data can come from malware information sharing platforms, otherwise known as MISP. And this information can come in as normally dedicated to one person's job that brings in the intelligence. So, just to put it in perspective as kind of more of a real life role, your cyber threat intelligence operator, your CTI, it's someone that basically scours different MISPs, and he or she is pulling back data relevant to their organization. Only pulling back data relevant to their organization because you're going to be inundated with different attacks and threats that go across the network and across the internet that happen in the world. Does it matter to you? Are you going to create a filter to identify a certain attack or CVE for a server that you don't even have on your network? That's where your CTI guy comes in. He understands what your network, the lay of the land. He understands what your business operations are, and he can assist in ensuring that you get the right data to make the correct filters and actually block out the right traffic, set the right alerts up, and ensure the playbooks are actually stopping actions that are malicious and not stopping standard business operations. So it's a key piece of the team. This person has to also be able to have really good communication skills, because if he needs to be able to get that data over to the SOC team as quick as possible, because attacks happen quick. Everything happens fast in the threat landscape. That was 4 Alpha, so now 4 Bravo. We're going to understand technology for security operations. So this is what I meant by the single pane of glass. So essentially, we in the field, a lot of people call these dashboards. This is what allows you to be able to see everything all at one time. So essentially, the screen that you're looking at now, this is what's going to be on your monitor when you're sitting in a SOC. You're going to be looking at your scene. You're going to be looking at data from different areas. So this dashboard is based off of specific cases, and this can be used to kind of manage cases. This is probably more of a SOC lead um, dashboard, whereas the actual tactical level cybersecurity analyst, this data will be something more similar to specific event logs, logins, audit logs, server logs, web server logs, Nginx logs. Depends on what your specific role is and kind of what your lane is within the organization. That's what your SIEM dashboard is going to be. So the single pane of glass allows you to correlate events. So if you see something go across the network, you're able to actually just look at a different screen or just look at a different portion of your screen to see exactly what is happening at a lower level in order to conduct a better investigation. So customization features. So we want to customize our themes to our business use case and what works best for our SOC. We want to figure out how to best have our tools work with each other versus siloed. So one of the things that can hurt you when you're sitting in a SOC is a vacuum of information. When tools don't talk to each other, it becomes cumbersome to really correlate the actions that are occurring on the network, because you're having to log out of things, log back into different programs. You might not know the password over here, or this system might be shut down, so you can't even get the logs that you want. What you really want to happen is you want all of this activity to happen on the back end behind the scenes. So what you want is an organization that has all of the tools within their team that talk to each other. And the way that they do that is through multiple ways, but the most common is an application programming interface. So what this does is it removes the human engagement from two different applications. This allows applications to query information from each other and use that to better make to assist the operator in making better decisions. So all the information is right there in front of them. So if I'm sitting and I'm looking at Kibana on my elk stack, but there is a Windows log that comes through, or there's a Splunk log that comes through that is in a whole different system. I want the elk and the Splunk instance to be able to talk to each other, and I don't want to have to actually kick off that interaction. I want the data to roll straight over to me as I need it. So think of this as like a back end plug that allows two systems or two applications to talk to each other. So webhooks are seen a lot in SOARs. So essentially what can happen is webhooks are your triggers. So one application sees something and it literally starts a chain of events. It triggers another application to do something, which that triggers another application to do something, and then that triggers maybe your front end to show on your single pane of glass that we talked about just now in your dashboard an alert. Before that alert actually happened, multiple things happened in the background. So maybe by the time you got an alert, the machine was already quarantined, or maybe by the time you got an alert, a user account was already disabled. So when you think about application programming interfaces, that is the vehicle or the pipe on the back end that they're used to talk. Webhooks is what is actually triggering the conversation to happen. So plugins and apps are just different kind of features that can be added to your application that you're using on your in your SOC that can feed different information. These became a lot more present when we started getting into IoT, um, cloud operations, when you have different things that kind of never were a part of the standard enterprise networks before. They had to basically add plugins in order to make sure that your SIEM and your SOARs can still work properly. So the applications were not purpose built from out of the box to ingest this type of data to be able to do these types of actions on maybe the cloud infrastructure or the ICS infrastructure. So what they were able to do was build these plugins and apps to make it so now your SIEM or your SOAR can actually trigger events that make maybe a garage door open up, or depending on your specific interface or your specific organization, maybe a pump will shut down or something based off of what actually happens. And without the plugins and apps, they won't be able to talk to each other because that was not how the original tools were built. The original tools were built to work through standard enterprise networks. Tell this computer to do this thing, but not tell this wireless access point to flush out its table or something. So that's where those plugins and apps come from, and the reason why they're used. So, like I said, this is a short lesson. Here's a summary. We went over is automation. Um, we went over seams and SOARs, how automation can improve efficiency, communicating within SOCs, the cyber threat intelligence, and how intelligence orchestration actually helps seams. Then we went into APIs and webhooks and identified how they're actually able to assist the cybersecurity analysts in getting their jobs done and how these systems are able to talk to each other. All right, so I've ended the recording.